In this video, we are going to discuss classification of systems in terms of inputs and outputs. So first classification is static and dynamic system. Static system is also called as memoryless and dynamic system is also called as memory system. So let us see the definition of static system. So to understand the definition, we must understand few concepts. So for example, let's say we have x of t with us, which is the input to a system. Now if we represent x of t plus some constant, let's say t plus t1, and one more parameter t minus t2. So if we look at these equations, x of t is called as present input, x of t plus something, that is to the current time instance we are adding something, so this t plus t1 is called as future input, and t minus t2, that is t minus any value, is called as past input. So we must remember these equations, and based on this we can define the system or classify the system as static and dynamic. So here a system is called static system if the output of system depends on only present input. Therefore, if we have the equation of the type like y of t is equal to x of t, so y of t will depend on only and only x of t, and x of t is the present input, hence the system will be classified as static system. Now the definition of dynamic system. So a system is called as dynamic system if its output depends on either past or future input, then the system is called as dynamic. So to represent it with the help of input, let us say if we have the equation as y of t equal to x of, let's say, t plus 2x of t plus 1. So if we look at this equation, here y of t is our output, x of t is the input, x of t plus 1 is also input function. So if you look at x of t, this term represents present input, and 2x of t plus 1. So t plus 1 means it is future input. Therefore, this y of t, which is output of our system, depends on present value as well as future value. Therefore, if we look at the definition of static, the system is static if output depends only on present. But here in our case, it is not simply present, it is future along with the present. Therefore, the system is called as dynamic, or it is also called as memory system. Now why it is called as memory system? Because in order to have the future input applied to the current time instance, we need memory blocks so that we can store this input and then we can apply it to the system. Therefore, this system is said to be dynamic or memory system. Let us see few more examples. Let's say we have second example as y of t equal to, let's say, x of or 2x of t square. Now in this case, here we have simply y of t is equal to 2 into x of t. But if we look it in a proper way, let's say if this value of t is 4, then we have 2x of 4 square, which is 16. So 16 is ahead of 4. Therefore, this x of t input will be treated as future input. And as we know, if current output depends on future input, system is classified as again dynamic. So in this way, we can classify the systems as static and dynamic depending on the values of inputs as present, past and future. So remember, if output is only dependent on present input, system is static. If output is dependent on either past or future or combination of it along with the present, then system is said to be dynamic system. Now the second classification is causal and non-causal. So let us start with the definition of causal system. A system is said to be causal if output depends on present and or past. It means if we have the output equation represented in terms of the combination of either present input or past input, then the system is said to be causal. So here we do not have future input, so no future inputs. In this case, the system is causal. Similarly, definition of non-causal system. So straight away here, output depends on future input. So if we have future input term in the equation, the system will be classified as non-causal. So let us see some example. So let's say y of t is equal to x of t minus x of t minus 2. So if we look at these equations, x of t is present input and x of t minus 2 is our past input. So here output y of t depends on present and past input, hence the system is said to be causal as we do not have any future term into it. Similarly, second example, let's say y of t equal to x of t plus 1 plus x of t. So here if we look at the equation, first term is x of t plus 1, which is future input. So no need to check other terms also. As we have future term into the equation, the system is straight away classified as non-causal. This x of t is our present input. So this is how we can classify the system as causal and non-causal systems. Now the third classification is linear and non-linear systems. To understand the concept of linear system, here we must have the insights of system. So we know that system is represented by a block. To this block, towards left we have the input supplied, towards right we have the output from the system. Input is generated by represented by x of t and output is represented by y of t. In this case, we need to classify system as linear and non-linear. So for linearity, this system must satisfy two principles. First is principle of homogeneity. So let us understand what is this homogeneity principle. So for this system, I have a pair that x of t is the input, and if I apply it with the system transfer function h, I get the output as y of t. Now instead of applying simply x of t, if I scale this x with some factor, let's say a, so a into x of t, so a is any constant value. So if I scale my input with certain factor, my output should be scaled with same factor, so output should be a into y of t. If your system satisfies this principle, so we are in the first step, that system can be a linear system. Again, this system should satisfy principle of superposition. So let us see what is principle of superposition. So let's say if I apply x1 of t as input to system, it will generate output y1 of t. If I apply second input x2 of t, it should generate y2 of t as the output. And now if I apply both the inputs simultaneously, so x1 of t plus x2 of t, then my output should be y1 of t plus y2 of t. This is the principle of superposition. So if I apply two inputs simultaneously to a system, my output should be again addition of the individual outputs. So if our system satisfies these two principles, it is called as a linear system. To solve examples on linearity, there are few steps which needs to be followed. So let us see those steps to classify system as linear and non-linear. So we have steps. So step number 1. So in the given equation, put x of t equal to 0. If you put x of t equal to 0 and check what is y of t. If y of t is equal to 0, it means system can be a linear system. Go to step number 2. In second step, apply x1 of t, you will get y1 of t. Apply x2 of t, you will get y2 of t, and find out y dash of t, which is equal to y1 of t plus y2 of t. Step number 3. Now apply both the inputs simultaneously. So x1 of t plus x2 of t, you will get y double dash of t. Now step number 4. Compare y dash of t with y double dash of t. If this y dash of t is equal to y double dash of t, then system is said to be linear. And if this y dash of t is not equal to y double dash of t, then you can say that system is non-linear. Okay. Now let us see a simple example. So let's say we have y of t given as log of x of t, and now we are supposed to prove whether system is linear or non-linear. So to prove it, we have to follow the steps given. So first step is we need to substitute x of t equal to 0. So if we look at y of t, it is log of 0. So we know that log of 0 is undefined for the base 10. So here we are not getting answer as 0. So our system is likely to be a non-linear system. So let us see the second step. In second step, we need to apply x1 and x2 simultaneously to get y1 and y2. So if I apply x1, I will get y1 of t equal to log of x1 of t. Similarly, I will get y2 of t equal to log of x2 of t, and y dash of t is equal to y1 of t plus y2 of t. So y dash of t is equal to log of x1 of t plus log of x2 of t. Now step number 3. In this step, we have to apply both the inputs simultaneously. So we get y double dash of t equal to log of, wherever you find x, replace that x with x1 plus x2. So x1 of t plus x2 of t. Now in next step, we have to compare y dash of t with y double dash of t. So if you look at this equation, here we have y dash of t is log of x1 plus log of x2. And if you look at y double dash of t, it is log of x1 of t plus x2 of t. So we know that we cannot represent log of a plus b equal to log of a plus log of b. Therefore, this y dash and y double dash are not equal. Hence, we say that given system is non-linear system. So this is how we classify a system as linear and non-linear. So next classification is time variant and time invariant systems. So let us see how we classify system as time variant and time invariant. So the simple definition goes in this way. A system is said to be time invariant if the output does not vary with respect to time. So remember, a system is time invariant when the output of system does not vary with respect to time. And for a time varying system, definition is output varies with respect to time. So now, to prove system as time variant and invariant, again we have certain steps. So let us go through these steps first. Step number 1. In the given equation of y of t, replace x of t with x of t minus k and find out y of n comma k. So in the given equation of y of t, so it is not n, so let me correct it, it is y of t comma k. So in the given equation, wherever we have y of t equal to some term of x, replace that x of t with x of t minus k and represent the equation as y of t comma k. Second, replace in the original equation t with t minus k to get y of t minus k. Step number 3, compare y of t comma k with y of t minus k. So if these two terms are equal, system is said to be time invariant system. And if this system's t comma k is not equal to y of t minus k, then it is called as time variant system. So let us see this with an example. So let us have example as, let's say y of t is equal to t into x of t. So let us prove whether this system is time varying or time invariant system. So we have the steps. So in step number 1, we have to replace x of t with x of t minus k. So here y of t comma k will be equal to, so our equation is y of t equal to t into x of t. So t will be as it is, and now this x of t is replaced by t minus k. Second step, replace t with t minus k and we obtain y of t minus k. So here wherever you will find t, replace t with t minus k. So in the equation we have t into x of t, so t will be replaced with t minus k. In x of t, again this t will be replaced with t minus k. Now in step number 3, we need to compare these two equations y of t comma k with y of t minus k. So if we look at this equation, y of t comma k is t into x of t minus k, and y of t minus k is t minus k into x of t minus k. So the second term x is same, but the multiplying factor of x in first case is t, and in second case it is t minus k. So these equations are not equal. Therefore, this system is said to be time variant system. So this is how we classify the system as time variant and time invariant systems. The next classification is stable and unstable systems. So let us see the definition of stable system. So here a system is said to be stable if bounded input produces bounded input. And in short, these systems are called as BIBO. Bounded input produces bounded output. Here, if I apply certain finite input to a system, my output should be a finite value. In such cases, system is said to be a stable system. For example, if I apply, let's say y of t is equal to x of t, so y of t is directly dependent on x, and if value of x is finite, my y will be finite. Under such cases, system is called as stable. And for unstable system, bounded input will produce unbounded output. So if we apply finite input to a system but the output is infinite, in that cases systems are said to be unstable systems. So let us take an example. So let us say y of t is equal to, so instead of taking a continuous time system signal, let us have example of a discrete system. Let's say y of n equal to x square of n. So let us see whether this system is stable or unstable. Now here the definition goes as, if we apply x as finite, my y should be finite. Therefore, in this particular case, if we apply a finite input to a system, that is x of n as finite value, its square will be a finite value. So here square of finite value is always finite. Therefore, given system is said to be stable system. So if we apply x as finite, y will be finite, hence it is called as stable system. So now the last classification of a system, invertible and non-invertible system. So let us see the definition of invertible system. A system is said to be invertible if we can reproduce input from the output of system. So if we can do it in a reverse way, generally we apply input to a system and system will generate the output. But if we can do it in a reverse way, from the output, if we can reproduce the input, the system is said to be invertible. And in case of non-invertible, we cannot reproduce the input from the output. So let us see a simple example now. Let's say y of t is equal to x square of t. So we need to prove whether the system is invertible or non-invertible. So here we have a square function. So here we can write x of t equal to, because we are supposed to produce the input from its output. So here we have x square. To remove square, we know that we need to take its square root of y of t. But in this case, this y of t will have the sign as plus or minus, because we don't know if x is negative, its square will be again positive. If x is positive, its square will be again positive. So here, for a square function, to find out x, we need to take its square root, and we do not know the sign of this function. So it may be plus or it may be a minus. Therefore, this system is said to be non-invertible. In this particular case, we can find out the magnitude of x from y. So for example, if x is, let's say, 3, if x of t is 3, we know that y of t will be 9. But if x is minus 3, still y of t will be 9. And now in such cases, if we try to find out x of t from y of t, so it will be under root of 9, which is equal to plus or minus 3, right? So taking square of plus 3 and minus 3 will be 9. But if we take its under root, we cannot determine whether it was plus 3 or minus 3. Hence, the system will be classified as non-invertible system. So in this way, we can classify our systems as static dynamic, causal non-causal, linear non-linear, time variant time invariant, stable unstable, and lastly invertible and non-invertible.